So, lecture unit 2. We're on lecture O, I believe. So I'm going to make one called lecture O. And like if you have a string, when would you have a string? Like if you ask for a value and you use .next or next line rather than next int to read it in. Well, I'm not going to do that because it gets annoying every time we run something, we have to type in something. But like we typed in 123.4. That's our string. 123.5. Now we want to convert it to a double. Double D equals, and in capital D because we're going to use the wrapper class, double dot parse double with a capital D string S. There. We have converted it to a string. Excuse me, to a double. What if you need to go back? What if you have a number and you need to convert it into a string? Like say we have a long set to 1, 2, 3. Really should be like real large, huh? You know, just some good reason for using a long, like 1, 2, 3 billion. So let's make it 12 billion. 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9. And we want to put that into a string. Now that number is too large to be an int, so it's underlining it, complaining, so I'm going to suffix it with an L. And I want to put that into a string. I could do this. S is equal to long dot toString parentheses L in parentheses. That converts to a string. But honestly, there's an easier way of doing it. You could just do this, and it's kind of a little cheesy shortcut. But if you do S is equal to double quotes plus L, it goes ahead and converts L to a string to append it to those double quotes. Either way works. One just looks more official, right? The other is shorter and easier to type. I would just go for that. Also converts to a string. But I want to see if that number is too big to fit into an int. So here's what I'm going to do. If parentheses L is greater than integer dot max underscore value, that means it's too large to fit into an int. It's larger than the maximum value an integer can hold. So system.out.println parentheses L is too large for an int. It's up to, you know, whatever purposes we would need to do to decide what to do about that. So the wrapper classes have the same name as the primitive types, but with an uppercase letter. Capital D double, right? Capital F float. The only difference is it's actually the whole word integer rather than just int. Just sits there and does that all day. Stop that. I guess it's not going to stop. There. All right. And you can also check the minimum value, right? The smallest value of a long or a double dot min underscore value. So here's an example of using a scanner to read in a piece of data. Do you want to win $1 million? If so, guess the winning number between 1 and integer.max value so that they don't type in a number that's too large. And then they call next line. Next line returns a string. And so the next line of code is going to be to use I see, they're leaving stuff out that they want us to fill in. So how do we compare the number with the winning number? Well, whatever the winning number was, we needed to assign it here, so we needed a random number generated there. I'm not going to bother. After we get our input, we would want to check to see if it equals our winning number. And so that would be integer.parse int parentheses input in parentheses or equals winning number. Like that. That would convert that string that they typed in to see if it matches. Just like we did here. Right. We took a string and we converted it. We could convert it into an int just as easily. Now, if we tried to convert this into an int, it would crash because that's not a whole number. Right? It's got a fractional component. So if I did int I equals integer dot parse int parentheses s in parentheses, that's going to be a syntax, not a syntax, that's going to be a runtime error. It's going to blow up. So when I run it, boom, it blows up because that cannot be converted into an int. It'd be a better idea to convert it into a double and then cast it to an int if it had to be a whole number. And that'd still be a bad idea. I'd convert it into a long, but even then, not perfect. But that's how you do it. But since that's going to crash, I'm going to comment that out. So the string class. In chapter 3, just like Shannon said earlier lecture, we saw several string methods. Char at, length, equals, and ignores equal case. These are all defined in the string class along with quite a few other methods. It's part of java.lang package. The Java compiler automatically imports all the classes in java.lang, so there's no need to add an import to get the string class. But some of the additional popular methods to the string class. Substring. You want to pull a substring out. What does substring mean? A part of it. Like if we do this. String space name equals Darth space Vader, in quote semicolon. And I just want to get out I want to get out these 3 letters. For some reason, I like those 3 letters a lot. So S is equal to name dot substring parentheses starting. What is that position right there? Or there, I said RTH. So what is that position of the R? What is its index? 2. It's 2, right? Because 0, 1, and 2. So that's a 2. And I want 3 characters. So 2 plus 3 is 5. And if I print them out, it would print RTH. The other way to think about it is that position 5 is right here. And so it starts at 2 and goes up 2, but not including 5. I just add. If I wanted to start here and I wanted to go to the end, well, what is that position? S is equal to name dot substring parentheses, that V starts at position, I have to count it out, 1, 2, 3, 4, 5, 6, 7. And I want the whole name, so it's 5 characters. So I'm going to go out to 12. 7 plus 5 is 12. But honestly, if you're starting a substring and you want it to go to the very end of the string, you could just leave that off. You could just make it substring starting at 7, and if you leave the second parameter off, it defaults to 0. So, or just substring 7 goes to end of the string. Oh, funny, their example involves Star Wars as well. Other ones. Index of searches a string for a specific character and returns -1 if not found. So we're going to search our string for an S, and we're going to find out it's not in there. So int POS for position equals name dot index of capital O parentheses quote S end quote. Find the S in the name, but there isn't one. So if parentheses POS less than 0, that means it didn't find it. System.out.println parentheses quote S not found end quote in parentheses semicolon. Else, let's print it out. Else system.out.printf parentheses quote S found at index %d end quote or \n end quote comma POS. Now I'm expecting it to say S is not found because it's not in Darth Vader. And boom, it blew up. What have I got going wrong? String index out of range, 12. Is that correct? 0, 1, 2, 3, 4, 5. Oh, V is not at 7, it's at 6. My mistake. So it should not have started at 7, it should have started at 6. And it should not have gone out to 12. It's 5 letters long, and so 6, comma 11, because 6 plus 5 is 11. Or we could have just done substring 6, and it would have started at the position and gone all the way to the end. Now let's see if it works. Right, and the S was not found. What if it had been? Then we would have gotten a real number, right? A number greater than or equal to 0. So POS equals name.index of parentheses quote capital D end quote in parentheses semicolon. What's that going to be? Where's the position of capital D in there? What is its index? Capital D in our string Darth Vader. 0. Yeah, so if we print out POS at this point, system.out.printf parentheses quote D found at %d \n comma POS in parentheses semicolon. Yep. And D was found at index 0. Why am I looking at that? What if you don't want to start at the beginning? You can specify a starting point. Like what if we're looking for an A, but we don't want to find that one? We want to find that one. Well, what we would do is we would give it a starting point, and it better be greater than starting point 1, because that's starting point 1. So if we want to find the second A, we would want to start at position 2. Let's write a loop that will print out the position of every A in that name. So let's do while, POS is equal to 0, semicolon, because that's going to be our starting point each time. Or maybe we could even give it a new variable name. Int S point for starting point, or just int start equals 0, semicolon. POS equals name dot index of parentheses start, comma, quote, lowercase a. We're going to find every a in the name. And I've done something wrong. No suitable method found for index of int string. Did I get them swapped? Oh, it's string, comma, int. Alrighty. Fine. Quote a, end quote, comma, start. And then while POS is greater than or equal to 0, because if it ever returns a negative number, it means it didn't find it. Curly brace, system.out.printf, parentheses, quote, D found at index, space %d \n, end quote, comma, POS, in parentheses, semicolon. And now we have to get the next one. So we're going to set start equal to POS so that it'll start searching at that position. But we don't want it to find the A every single time. And so if A is at position 1, if POS is equal to 1, then we want start to equal to 2. So we're going to modify the value of start, and we're going to say start equals POS plus 1, semicolon. And then just copy and paste this statement. That one right there. Like that. Now if we run it, hopefully, since Vader's first day is at position 1 and the second one is at 2, 3, 4, 5, 6, 7, when I run it, it should say that the A was found at 1 and 7. That seems to be the case. There's also last index of. If you don't care about all the intermediate ones and you just want to get to the last one, then you can do last index of. Works the same way, just goes from the end rather than the beginning. So last index of is identical to index of, except it looks right to left rather than left to right. So formatted output with the printf method. You should strive to make the program output be understandable and attractive. So you should use printf. Fortunately, we've been doing this all along. They're getting a little bit more sophisticated. They're showing how to use commas in your output. And it looks like they're showing how to use parentheses around negative values. So the system.out.printf method generates formatted output. We've been using that a little bit. We're going to learn how to use it better. So the printf uses this formatting string right here. The formatting string has a lot of little factors in it that can work. Like that dot means how many decimal places you want. This means 2 decimal places. So if the number is 1.34567, it'll just print out 1.34. 2 decimal places. So here we go. It starts with a percent sign. No, that doesn't tell us much. Let's keep going. After the percent sign are some flags. Like we used just %f. And so it didn't have any flags, it didn't have a width, and it didn't have a precision. So like %f just means a floating point number. But we can get more sophisticated than that. How's about we set, did we have a number named d? Yeah. d is equal to 1 divided by 7.5 semicolon. I don't know what that's equal to. I just want it to be equal to some long number. System.out.printf parentheses quote %f end quote or %f \n end quote comma d in parentheses. That's just the first way we're going to print it out. I'm going to copy and paste that so that I can say I want that number to only have 2 decimal points. And then I'm going to print it out a third time, and I'm going to say I want that number padded out to be 12 spaces long. So I made it 12.2f. And then I'm going to say I want it all padded out with leading zeros, right? You've seen that before. Like if you have the number 6, it'll have 00006. We can do that. So put a 0 in front of that. 0, 1, 2. 0 means padded out with leading zeros. It's supposed to occupy 12 characters total. It needs a decimal point followed by 2 digits. Let's see how that looks. And there we go, right? First time we printed it out, it was 0.1. That's because printf, if you do not give it any more sophisticated qualifiers, prints it out to 6 decimal points. That's why we saw that. But then we said, no, I only want 2 decimal points. And so it did that. And then we said, no, I want it padded out to 12 spaces. And it did that. Padded it out to 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we said, yo, I want it to be 12 spaces wide, and I want it to be filled with zeros. And that's what we got here. There also seems to be one for adding commas, because on that previous slide, they showed adding commas. I don't remember how to do that. I hope they tell us, because that's pretty neat looking. So, types for printf, you can display strings with %s. D's are for decimals, interlong. I always wish D stood for double, but it doesn't. F stands for floating point, which are floats and doubles. E is a nice exponent. Let's print our number out as an exponent. So I'm just going to copy and paste this one more time. This is the one that I'm going to copy right here, and I'm going to change that %f to a %e. And there we go, in scientific notation, in exponent form. That's that. You can also left or right justify. You see how here, this is left justified? Excuse me, right justified. All the spaces were padded in front. Take this one here, this 12.2f, copy it, paste it, but make it minus 12.2f. Put the minus sign there, and then just for funsies, let's put some exclamation marks here. Why am I doing that? Just so that you'll see it's really 12 characters wide. And there we go, right? It's 12 characters wide, except the minus sign told it to be left justified, meaning go up to the left margin. Without that minus sign, it was right justified. And it's still 12 characters wide. I'm looking for that thing that'll add commas, though. Notice that they use underscores to pad out numbers to make it easy to read. You can do that, and I always forget that you can do that. Right, like you could say D is equal to, and I want to equal it to 3 billion, 0.5, 3, underscore, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot 5. Now it's equal to 3 billion, dot 5. The underscores represent commas. What if I start throwing in a whole bunch of underscores? This is just a test. Can I just like use them all recklessly? Don't do this. This is just a dumb test. I want to see what happens. Yeah, what do you know? So it completely ignores the underscores. So if you want to be annoying, you could put all those, put those inside your numbers to be annoying. They haven't shown us how to do the commas yet, so onward to the next slide. Precision. Precision works with floating point numbers, says how many decimal points to be displayed. We know how to do that, like that .2 or .4 would display 4 decimal places. The width. We know how to specify the width. It's the number before the period, like 12.2. The 12 in front of it means we're going to pad it out with zeros or spaces out to 12 spaces. That's the width. For the C++ programmers, that's the same thing as doing set W. Flags. Flags give us supplemental formatting features. We already saw the 0 flag. If you put 0 after the %sign, it fills it with zeros where the spaces were. If you put a comma, it puts commas. Excellent. That's what I wanted to see. Why did I close it? There. So now that we have this number that's equal to 3 billion.5, system.out.printf, parentheses, quote, %f, \n, end quote, comma D, right? Just print that number out like normal. And so it's going to display 6 digits after the decimal point, most likely. But then copy and paste that and put a comma after the %sign. And the comma means format it so that it's all nicely formatted where you have a comma every 3 spaces. And that's what we see. I really don't like seeing all those zeros there, so I can make it like .1f or .2f or .3f. So % comma .3f. That will only display 3 decimal places. Or .1f, right? Maybe I only want 1 decimal. And that's what I got. What if I wanted a $sign in front of it? Well, you just put a $sign here, right? You could put anything you wanted to. D equals, right? $sign. And then that's our formatting string. From there to there is our formatting string. So I'm going to put some comments here. I just copied that formatting string and I'm saying % begins the formatting string. After that comes flags, like 0, fill with zeros, minus, which means left justify, comma, which means use commas, and then you can specify the first non-zero number specifies the width. But we don't have any. numbers. But we could have, right? We could have put some numbers here, like 20 or something that would fill it up to 20 spaces. But we don't have any in this example. And then decimal point followed by digits specifies precision, number of decimal places. So in this particular case, what does this mean? If we have percent, comma, 0, now I'm going to leave the 0 off, percent 20.3f. If that's our placeholder, it means 20 spaces wide with 3 decimal places, 3 places after the decimal. Use commas, every 3 characters. Just to make it look pretty. Now that's all for %f. %d works the same way, except you don't do that part. Because %d means integer, and an integer can't have decimal points. So, since integers don't have decimal points, all the flags apply except for decimal point followed by digits, or except no precision specifier. So if you have % minus 20d, it again means 20 spaces wide, left justified because of the minus, and it's an integer. The f meant floating point, which I should have added to what this was specifying, right? So somewhere up there, I thought we had a long. Yeah, there it is, a long. Well, let's do a loop that prints data out that's going to be nicely formatted. And we will use a nested loop, and it'll be the last thing we do today. So for parentheses int, like column C equals 0, semicolon, or how about starting at 1, because 0 times anything is 0. C is less than 5, or less than or equal to 5, semicolon, C++, curly brace, and here's our inner loop. For int r, standing for row, equals 1, semicolon. R less than or equal to 5, semicolon. R++ in parentheses. We're going to print out r times c. So it's going to be a multiplication table. System.out.printf. And these are integers, so we're going to use what? %d or %f? Yep, %d. End quote, comma, r times c, in parentheses, semicolon. After it's done printing an entire row, it needs to hit the enter key. So after that, we're going to print line. System.out.println, parentheses, in parentheses. So it's printing out a multiplication matrix. I mean, not a huge one. It's only out, 1 to 5, but it looks nasty, right? It's not all spaced out appropriately. So let's make each one the same width, like %4d or %3d. Now it looks better. What if you wanted each, these numbers are lined up by their right margin. If you wanted them to be lined up by their left margin, which I don't think is as pretty, you'd put a minus sign here after the percent. Now I'm probably going to take that out, but I just want to see what it looks like, see if I like the way it looks. Nah, for some reason, my eye anyways likes numbers to be lined up on the right margin. So I'm going to take that out. But what if I wanted them all filled in with zeros for some reason? I think this is going to look ugly, but let's experiment. Yeah, that didn't work. But I guess we could put a space after them by putting that. And then it would work, right? Oh, where'd that S come from? That wasn't supposed to be there. Yeah. Again, that's too much noise. I don't like the way it looks. So I'm just going to go back to my original plan, which was %4D. Alrighty. That making sense, gang? Yeah, we've been using %F already, so I bet that pretty much made sense. %S for string, %F for float or double, %D for int or long, and %E for scientific exponent. There's even others. There's one that means hexadecimal. I think it's %X. All right, let's make some homework. The best part of the day. Making up homework for y'all.
I have a printed copy of this lecture.
Yeah, sure. I'm going to add some comments. I don't normally do this. This is the end of main, and this is the end of our class. Okay, so homework. Step 1, create a string named or called name. 2, set name. I guess it could be a lowercase n, right? We always use lowercase letters. Set name equal to this string. Hello, period. My name is, and then use a single quote, and then put your own name in there. Right. Your name here. Right. Just fill that in. End quote, exclamation mark, double quote, semicolon. That's what I want you to set that name field to. And now we're going to use index of to find the position, the first quote, and then the last quote. So use index of to find the position of the first apostrophe. And store that in P1. Use last index of to find the position of the second apostrophe. And then 5, use substring or name.substring to get the characters from, oh, I forgot to specify what to store that in. Second apostrophe, and store that in P2. And then use name substring to get the characters from P1 to P2 plus 1. And then 6, storing the results in a string named into, and then print into. And if you've done it right, then it would print out your name here. Something like that. We can make it a little bit more sophisticated. Something to worry about is what if there were no apostrophes? It would crash. things like that, but we'll save that for the next homework assignment. Making sense, gang? Okay, cool. All right, let's stop here. There should be a Dropbox already created, so you can upload your notes or whatever you want into it.